Earth Science, second semester study guide. You just have to copy down the question or the answers that I have shown here on the paper. I'm not going to be doing every single problem. There are some that we're going to skip because we didn't cover it all that thoroughly during the school year. Number one, describe the features of a youthful river. Those are ones that have V-shaped channels, rapids, and waterfalls. The V-shaped channels are because the rivers are fairly steep, and so they are eroding down into the dirt pretty quickly and making the V shape, the steep banks. A mature river have large floodplains, and these floodplains are going to be pretty wide because there's been lots of time for the rivers to erode back and forth and to erode their banks down. And it has lots of meanders, which are S-shaped turns. The river starts at its head. That is the top part of the river, the highest elevation. And when it empties into a larger body of water, we call that area the mouth of the river. A small river that feeds into a larger river is called a tributary. The flat area that is often covered by water during periods of high precipitation and runoff is the floodplain. An S-shaped bend in the river channel is called a meander. And remember that meanders can change their shape over time. As they grow bigger and bigger, they can actually connect with one another and create an oxbow lake. Number 8, an oxbow lake. Number 9, we're going to skip. Number 10, how does permeability of a soil sample affect the accumulation? We're going to skip that one too. Number 11, when looking at a soil sample, how can you tell which one is more permeable? It's going to be the sample that has more open spaces. That way water can run through these spaces more easily. We're going to skip glacier. Number 13, glaciers change the land by generally bulldozing it flat. Illinois is very flat, partially because of all the glaciers that have run over it. As the glaciers bulldoze the area flat, they do push the dirt around, and one of the things that they can make at the end of the glacier is a pile, just like a bulldozer makes a pile, and that's called a moraine. There are other ways of the glaciers making piles of stuff, and one of them is called a drumlin. This is a canoe-shaped or a turtle shell-shaped. It's a low, smooth hill called a drumlin. These can form underneath the glacier. So glaciers don't make everything perfectly flat. They can make just the larger hills smaller. Skipping number 16. Number 17, a depression made when ice breaks off a glacier during a recession is called a kettle. And sometimes that can fill up with water and it becomes a kettle lake. Number 19, an eroded seamount creates a flat-topped guyot. Remember that a guyot is like a volcano under the water, and the top is eroded flat by all the wave action. Number 20, deep valleys in the ocean floor are created by subduction. Those are called trenches. Those are the deepest parts of the ocean. Number 21, the edge of a continent that's covered by shallow water and coarse sediments is the continental shelf. Here we have a diagram of the ocean. At the very deepest part of the ocean, we have the abyssal plain, then we have the continental rise, and then this flat area that's relatively shallow in water. It is covered with water here. That is the continental shelf. The flat bottom of the ocean that's covered with fine sediments is the abyss. Sometimes it's called the abyssal plain. These fine sediments are oftentimes from dead plants and animals. Number 23. The chain of volcanic mountains associated with hotspots are called seamounts. Skip number 24. 25. The dissolved gases and dissolved solids in the ocean come mainly from the rivers. There may be some from other locations too, but this is the majority of it. We're going to skip 26. Skipping all the way to 33. Let's see here. Number 34, describe the neap tides. These are the smallest tides, and that's because the moon and the sun are not on the same side of the earth. The moon is pulling the oceans in one way and the sun is pulling it in the other way, and they almost sort of cancel each other out. The spring tide is when the sun, moon, and earth line up, and this is when we have the highest tides. So here's a diagram. We have the sun, moon, and earth, and both the moon and the sun are pulling on the oceans in the same direction, so we have the highest tides there. Number 36, describe a hurricane. These are the largest storms on Earth. They are like pinwheels. They normally form in the North Atlantic. The layers of the Earth's atmosphere start off with the troposphere at the bottom, and then the stratosphere, mesosphere, and finally at the top, the thermosphere. The mesosphere is the third layer, and that's where meteors burn up. The stratosphere is the second layer, just above the troposphere, and that's where the jet stream and the ozone layer are. The thermosphere is the top layer, or the fourth layer, and that's where satellites are found. Satellites are not technically in outer space. The thermosphere is part of the atmosphere, it's just that it's so incredibly thin that it really isn't worth talking about. Number 41, the troposphere. That's the first layer. The troposphere is the first layer, the bottom layer, and that's where all of our weather is. The jet stream is a channel of high-speed winds way up in the stratosphere. The ozone layer is an area of gases that protect us from UV radiation. The ozone is a molecule of 3 oxygens, and way up in the stratosphere, the concentration of that is higher than in other places. We still have other gases in this ozone layer. It's just that the ozone molecules are more plentiful here than in other places. Number 44, rotation is the spinning of a planet. And for the Earth to spin once is 24 hours. That's what we call a day. Number 45, a day. 46, revolution is one orbit. For the Earth, it's 365 days. Or we could also call that a year for problem 47. Number 48, the summer solstice is when the northern hemisphere of the Earth is tilted towards the sun. That way, as the sunlight comes and shines on the northern hemisphere, it's fairly direct. And so we have warmer weather at that time. And the exact summer solstice day is the first day of summer. The winter solstice is when the northern hemisphere is pointed away from the sun. That way, when the sunlight hits the northern hemisphere, it's more of a glancing blow. It's at more of an angle, so it's not as effective at warming the ground, and it gets cold. So the winter solstice is the first day of winter. Number 50, the equinox, we're going to skip. Number 51, the days get shorter from summer to winter. Number 52, as we go from winter to summer, the days get longer. Number 53, weather moves generally from west to east in the United States. So most of our weather comes from Minnesota and the Dakotas. Number 54, a cold front goes with high pressure since the temperatures are low. Cold air is going to be very dense, and so it weighs down heavy on the ground, and so that's why we have high pressure then. Number 55, a warm front is low pressure since temperatures are high. You've heard of warm air rising, and so if it's rising in an area, it's not going to be pressing down on the ground very much. And so we have low pressure. Number 56, when reading a station model, we can tell how cloudy an area is by the circles, whether they are filled in or not. If you have a circle at a city and it is not filled in, that means that the sky is completely clear. If the circle is half filled in, then it's going to be 50% cloudy. Half the sky is going to be clouds. Number 57. When reading a station model, how do you tell how windy it is? You look at the feathers off the circle. So here are the circles that we were referring to before in problem 56. These can be filled in to various degrees according to how cloudy it is. But it always has a stick that shows us where the wind is coming from, and the number of feathers here tells us how windy it is. The more feathers, the more wind there is. So this would be very windy weather here, and this would be not very windy. Number 58, we'll skip for now. Number 60, there should have been a blank right here, and the answer is a cold front. A cold front is where the mass of cold air moves in under warmer air, produces storms. They're short, scattered, and violent. So when you have a cold front, the weather is going to get colder. Number 61, a warm front is when a mass of warm air moves over a mass of cold air, produces storms that cover larger areas, and it makes the weather generally warmer after the warm front passes. Number 62, with a high pressure, once again, we're going to have cold and clear weather. It's cold because cold air is more dense. Cold things shrink for the most part. So cold air shrinks and gets more dense, and it pushes down on the ground more to make high pressure. You've heard of cold sinks and warm air rises. So when you have cold air sinking, we don't make clouds, so that we have clear skies. When we have a low pressure system, that means that it's going to be cloudy and warm. Warm air rises, and so if it's rising, it's not pushing down on the ground as much, and we have low pressure. When you have air rising, that's when clouds can form. When the warm air rises, it cools off, and things condense into droplets to make clouds. Number 64, the temperature to make snow is 32 degrees. Number 65, the half-life. That's the time for half the radioactive element to decay into something else, half-life. After one half-life, we'll have half of the original material left over, and half of it has turned into other stuff. After two half-lives, we have half of a half, which is a quarter. After three half-lives, we cut this in half again. Half of a fourth is 1/8. Cut that in half, you get 1/16. Cut that in half, you get 1/32. We're going to skip number 67. Number 68. The Precambrian era was the longest. It was the first era. Let's write that down as well. It was the first era. It's not divided up into any subgroups. The Paleozoic era is the second longest. And in terms of history, it's right after the Precambrian, so it's the second era as well. Mesozoic era, that's most famous for having the dinosaurs. The Cenozoic era is today's era. It's also the shortest. So as we go through history, Precambrian is first, and it's the most long. The second longest is the next era, the second of the historical record. And then we have the dinosaurs before us, and then we have the Cenozoic era, which is today, the most recent, the shortest. Number 72. If you look at all the radioactive dating, the estimate that they have is 4.5 billion years for the age of the Earth. Number 73. As we look at the rocks from the Precambrian era, and we look at those fossils, we look at the fossils in Paleozoic rocks and Mesozoic rocks and then Cenozoic rocks, the pattern is that we see more complex fossils. Number 74, the law of cross-cutting relationships is that faults come after the rock layers that they are breaking. So you first have to lay down the rock layers, and then the faults split the rocks and make them slide this way and that. The law of superposition, that's talking about the position of rocks. That says that the lower the layer, the older the rock is. The principle of uniformitarianism, we can look at this term here, uniform. That means everything's the same. So the principle of uniformitarianism means that today's events are similar, pretty much the same to all the events in the past. So we can figure out what happened in the past by looking at similar processes happening today. The principle of original horizontality, again, looking at the term horizontal, that means that we assume that the layers of rock were first laid down relatively flat. Number 78. Disconformities, those are things like faults and the bending of rock layers, happens because of the tectonic plate movement. Number 79. Angular unconformities happen because of uplift. That's the plate tectonics lifting up on rocks, and that happens to form slanted rocks in our diagrams. For this stratigraphic column, the oldest is the lowest, F, and then the next oldest is E, and then we form D, C, B, A. As we go higher and higher, we get to the younger and younger rocks. Number 82. The Milky Way is a spiral galaxy. To define the universe is just simply everything. You name it, it's part of the universe. The galaxy is a group of stars, comes in different shapes. The solar system is just the sun, planets, moons, and the other things like asteroids, comets, and not much else. Meteors, maybe. Number 86, we start off at Mercury, then we go to Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That's going away from the sun. And finally, the asteroid belt are the rocks between Mars and Jupiter. Last page, number 88. The Oort cloud is where we think comets originate from. The Oort cloud is way past Pluto. Number 89. As we get farther out away from the sun, the orbit is farther out, we have longer revolution time. Number 90. The Earth is the only place that we know of that has liquid water. Number 91. To have a lunar eclipse, the Earth gets in the way of the sun shining on the moon. The Earth is in the middle. In a solar eclipse, the moon gets in the way of the sun shining on Earth. So the moon's in the middle. Number 93. The moon changes phases for both 93 and 94 because it revolves around the Earth. And lastly, the final question. Congratulations, you made it to the end. It's a star. When you get all done, show your teacher. Thank you.